Welcome. This question says a horizontal 7 Newton force pointing to the right accelerates a 5 kilogram block from rest to the right through a distance of 9 meters along a smooth and level surface. What is the block's speed at the end of the journey? So let's visualize. Here we have a block. It's 5 kilograms. We're going to apply a force of 7 newtons to the right. And we start off with V initial equals 0 meters per second. And then at some time, some position later, so let's imagine that is 9 meters. And at that point, our block is over here, it's 5. And V final equals something else, and I don't know what it is. So basically, I could approach this using kinematics. It's a constant force, meaning a constant acceleration, so I could use kinematics. But let's try using some of the newer ideas, and we're going to think in terms of work. So what I'd say is that work is equal to my change in energy of the system. Now in this case, I'm not climbing any hills, so I've not got a change in gravitational potential energy. There's no springs around, so there's no change in spring potential energy. So what I can say here is that work is equal to my change in kinetic energy in particular. It's work energy principle. So basically what this says is that my change in kinetic energy is my K final minus my K initial, and I can expand that and say, okay, that's a half V final squared minus 1/2 V initial squared. I used K is equal to 1/2 V squared for that bit. Say my work is equal to 1/2. I know the mass is 5. I want to find V final. And this is minus 1/2. I know the mass is 5. I know the V initial equals 0. What is this work equal to? Well, if I remember that work is equal to force times the displacement the force moves through. So then in this case I can say, oh, this is equal to plus 7 multiplied by plus 9. They're both pointing in the same direction. So that would give me 7 9s is 63. 63 is equal to 1/2 times 5 times Vf squared minus 0. So Vf squared is equal to 63 times 2 from the half over 5. And that's going to equal, let me just get my calculator, 63 times 2 divided by 5 equals, and that's going to equal 25.2. So that means that Vf will equal the square root of 25.2, which equals 5.02 meters per second. It's positive 5.02 meters per second. And that's there. Now, I could have done this using kinematic equations, and it will get you the answer. You use F equals ma, you find the acceleration, you then use your kinematic equations to find the answer. And you can do it. You can do it both ways. You now have 2 groups of tools in your toolbox, and one is very familiar. Using kinematic equations is very familiar. My advice is you practice using work energy, because if you don't practice it, you're not going to remember that it's there. And I can set problems up where you actually cannot use kinematic equations. I don't give you enough information. So watch out for that. Okay. Anyway, 5.02 is the answer, and there we have it.